All right, so this is the final packet for the distance learning. And you can see the dates say May 5th through the 28th. So that's how you know it's which one we're looking at. And for this one, they're not calling it day 1, day 2, like that. We're going to just call it by the actual date. So this is the math section for May 5th. And we're going back to our statistics and probability lessons on scatter plots. So we have an example here, and remember when we do this, we aren't trying to connect the points. We're just looking for overall patterns and trends, and then we can make a line to kind of represent our data, and then we can use that line to make predictions. So for example, if we're looking at these two graphs, and it looks like we're comparing test scores. So the trends that we see, they're going up. So it's a positive correlation or a positive association. And all of that's kind of reviewed on this page. So there's nothing for us to do here besides to just review this concept that we've learned, but it's been a while. So take some time and look that over. And then here's some problems for us to do. So a couple things to remember. We have a lot of words that go with this topic specifically. So there's correlation mentioned on this page, but then over on the example page, we have other words, but they all mean the same thing. So we have at the bottom positive association, or it could be a negative association. At the top, it says the word trend. Okay, so a positive trend or a negative trend. So it's all talking about the same thing. So is the data going up, or is it going down, or is it just all over the place? So just keep that in mind. So that's what correlation is. So how does the data look? Okay, so number one, so there's all the same type of questions for the different graphs. And it's kind of hard to see the points, but maybe we can figure this out. Okay, so the first one, it says, what type of correlation does this graph show? All right, so we could see the points are kind of starting up over here, and then they kind of go down to the right. Okay, so if I'm just, you don't have to draw the line, but it helps me to kind of see if there is an association or a correlation. So yeah, I can see that if I can draw a line right through the middle of all those points. Again, it doesn't have to touch any point, and this is called our line of best fit. So it is clear that it is decreasing. So we can say, I don't know, it's right below. So the answer for question 1 would be a negative. So this is a negative. We'll just use the same word that's in the question, correlation. Negative correlation. Okay, again, we could also say negative trend or negative association, but I'm just going to use the word that was used in the question. Okay, the second one, it says predict the distance traveled at time equals 2. All right, so whenever we have a prediction, then we are going to need a line of best fit. So the line that I drew was okay, but it's not really straight. So let me redo that. So if we remember in class, what I recommended was using a toothpick or even a piece of spaghetti, uncooked, so that you can lay it on your graph and adjust it until you see where you have about the same number of points above the line as below the line. So you need something that you can see both sides of and something that's pretty thin to represent that line. So here's my line, and it's asking at time equals 2. So time is the x-axis, here's 2. So once we have our line, we can go from there up to the line And then when we hit the line, we go left, and that's what we're looking for. So the distance at time 2, so at time equals 2, the distance is 50. And I don't know the units. 50 what? I'm not sure. So it doesn't tell us. Okay, and then it says predict the distance traveled at time equals 3. Okay, so here's time equals 3, and then we do the same thing. We follow it up to the line of best fit, and then we go left to the y-axis, and we see it is at 40. So at time equals 3, the distance is 40. So let's kind of go back to our original, or our first question. So a negative correlation means it's decreasing. So does that make sense with what we have here? So at time 2, the distance is 50, and then at a greater time, the distance is less. It's at 40. So it is decreasing. So it should make sense. Okay, so that's how we do those. The next two are the same types of questions. So we're going to need the line of best fit. So I'll help you with that. And then I'll let you answer the other questions. So line of best fit, remember, we want a line that goes through the data. It doesn't have to touch any points, but it needs to go in between. And we want it so that there's about the same number of points above the line as there are below the line. So the second one, maybe I can make these a little bit easier to see. So here's our points. Okay, it's kind of like, I don't know, almost like an X. So remember, we want a single line that will represent this data. And yeah, in my opinion, there is no correlation. So we can't make any predictions. If there's no correlation or no association, then we can't draw a line of best fit and we cannot make any predictions. So this one would be no correlation. So that would be the answer for question 1, no correlation. Okay, again, right here, no obvious pattern. Okay, the points are all over the place. So that's what we have here. And then it says predict the distance at 7. So look at this. This is exactly how there's no correlation. So if we go to 7, we have a point at 10, distance 10, and we have one at 70. So those are not even close to each other. Okay, so we cannot predict. We have no idea. All right? So if there's no correlation, then there's no predictions. All right, so that one's done. I mean, we just have to write out, we cannot predict because there is no correlation. All right, and then the last one, so those points, we can see they're kind of clustered together, which is what we want, and it's definitely going up to the right. So if we look at a line of best fit, yeah, something like that. Okay, again, trying to figure out a line where there's about the same number of points above the line as below. So let's just count 1, 2, 3, 4, 5, 6, 7 above, 1, 2, 3, 4, 5, 6, 7, 8 below. That's pretty close. I mean, we could adjust it a little bit, but that's pretty good. And that one, since we do have a correlation, it's a positive correlation, and we can make those predictions. So again, I'm going to let you finish that one up. And that is it. So it looks like these lessons are going to be much, much shorter. So hopefully you guys are able to get these done a little bit easier.